Sample problem. Consider 3-point charges located at the corners of a triangle as shown in the figure, where Q1 equals Q3 equals 5 microcoulomb, Q2 equals -2 microcoulomb and A equals 0.1 meters. Find the electric field on Q3. Refer to the figure. At the location of Q3, the total electric field is a vector sum of the individual fields produced by Q1 and Q2. Note that the field exerted by Q1 on Q3 lies on the x and y plane, so we consider its components. So we write an expression of its component as a function of theta shown in equation A and B. So we write the sum of fields along x and y as in equation C and D. Let us consider solving the angle theta. By geometry we see that the sine and cosine of this angle can be expressed as these functions here. Consider the adjacent and hypotenuse parts. For the cosine function we have equation E and sine function as shown in equation F. We will substitute them later. Recall the expression of the electric field by two charges. We have equation 7. So we have for the field along x, which is the sum of the components from field 1 and field 2. We get that the sum of the field is a negative value that suggests that it favors going in the direction along the x-axis as indicated by equation G. Considering the field along the y-axis we have from equation D. We get that the net field along y is pointed upwards since it is positive as shown in equation H. Here we have the resultant field, which is expressed by its components along the x and y axis from equations G and H as shown by equation I. Based on the signs of its components, the resultant is oriented on the second quadrant as shown by the figure. We can also solve for the magnitude and direction of this resultant electric field. For the resultant we use the Pythagorean theorem as shown by equation J, which is about 1.5 meganewtons per coulomb. For the direction, we take the negative x-axis as the reference, and using the tangent function where we take its absolute value we get that the resultant field is 8 degrees with respect to the negative x-axis.